A standing electromagnetic wave in a certain material has a frequency of 2.2 times 10 to the 10th Hertz. The nodal planes of the magnetic field are 3.55 millimeters apart. You need to find the wavelength of the wave in this material. Well, the problem gives you the nodal planes of the magnetic field. And you know that the nodal planes of the magnetic field are a distance half a wavelength apart, which means that half a wavelength in this case equals 3.55 millimeters. And from here we can find the wavelength as 2 times 3.55 millimeters, which gives us a value of 7.10 millimeters for the wavelength. In the second part of the problem, we need to find the distance between adjacent nodal planes of the electric field. Well, the spacing between the nodes of the electric field is the same as the spacing between the nodes of the magnetic field. They oscillate in phase. Therefore, that spacing will be also half a wavelength, or 3.55 millimeters. In the last part of the problem, we need to find the speed of propagation of the wave. Well, the speed of propagation of the wave is related to the wavelength, and it is related to the frequency. So we can write that the speed is frequency times wavelength. We know the frequency and we know the wavelength, so we can find the speed as frequency, which is 2.2 times 10 to the 10 Hertz, multiplied by wavelength, which is 7.10 millimeters, or 7.10 times 10 to the minus 3 meters. And we get a value of 1.56 times 10 to the 8 meters per second. As you can see, the speed of this electromagnetic wave that travels in a certain material is smaller than the speed of light c.